Anything else?
Too many choices.
Too many
Too
choices.
many options. It's like you're comparing a blue to where's that other blue kind of deal. Like
Yeah.
like the purple or the green. Where's the green? Oh, there it is.
How many of
It's
you?
not fast to get the concepts.
Absolutely, you're doing a lot of trips
Yeah.
left and right with your eyes. I saw another hand back there. Yeah.
I don't know if there's a rule regarding this, but I would say that as far as pie charts are concerned, if you get to more than 3 or 4 elements,
Yeah.
it starts getting overwhelming.
Absolutely. There's varying numbers out there. I've heard 5 or 6 might be acceptable, but 3 or 4 might be a good rule. When I used it, I just used it to show 2 numbers. But this is actually pretty, we're talking about data density and consuming all this information in the world. This is actually pretty data light as well. There are 1, 2, 3, 4, 9 data points in total here. Yeah.
Blue and the purple are kind of close to each other, so it may be interpreted differently on different computers.
Yeah, for sure. How many of you have red-green color deficiency? That could be a problem as well. So we don't have 9 different slices on a pie chart here. This is a real graphic we found online. Any comments about this one? Yeah.
I think they probably could have chose a different scale for the y-axis.
Yeah, they might have been able to choose a different scale for the y-axis. I think that's not an unreasonable statement.
Amongst other things, right?
I think this might have just been sloppy on the part of whoever put it together. What is the y-axis, actually? What is it showing us? Is it showing us anything, or is it just kind of placed there randomly? This one was not done in jest. I actually did find this one. So a lot of curious things going on today. What about this, though? Kind of the Teletubbies color scheme.
I don't know what I'm looking at. There's no title. There's
Yeah, there's an omission of data. That could be my fault because I kind of just plucked these images online. But about the data graphic itself, yes?
Like for the blue columns, I can't even see how high they are.
Yeah, we're using a lot of, it's not too different from the background, is it? And really, are the colors necessary? Yeah.
They're also lying the y-axis. There's zooming in.
Shh, I'm going to get to that. No, I'm joking. You're absolutely right. It starts at 20,000, and that is known as the lie factor. This one has quite a bit of a lie factor. We'll talk about that in a little bit. We've already talked about pie charts. The only thing I wanted to highlight here were this extraordinary use of gradients in everything that we see today because they're so cool. Really, is it necessary? And forget this. Let's take a look at something that actually doesn't look unreasonable. How many of you can spot a big problem here? You're not allowed, John, sorry. Yeah.
2010 and 2012 are problematic. Well, I mean, they're all problematic, but 2012 is lower, it should be higher.
They fixed the sense, by the way, if you go back to this one. It's done properly now. And again, to your point, the y-axis is lying. And also not an incredible amount of information here. That's a lot of space used up for 4 numbers, really? Yeah, it's not just isolated to one news organization. I don't think, if you're still fetching for the answer, the slices don't quite add up to it. So that's our little journey through the Hall of Shame. And we can laugh about it here, but how many of you have seen similar atrocities, if not quite so bad, in your daily work or even at school? And so really, when I learned about data visualization, when I started studying, a lot of the principles weren't obvious to me, but now when you kind of know what they are, even without knowing what the principles are, it's kind of hard not to miss them. So what are these principles? There are many. There's so many books on this. I don't have a lot of time today. I could probably go on until tomorrow morning, if I had the time and your energy. But I've chosen 5 to hopefully leave with you today. So principles of data presentation. Choose the most appropriate tool for the job. Show the data and do not distort it, kind of do no evil, do no harm. Show context, relationships, explanation, causality. To clarify, add more detail. And 5, good design is as little design as possible. I took that from Data Ramsey's, an industrial designer, and that was one of his principles that really struck a chord with me. So let's talk about the first one, choosing the most appropriate tool for a job. When should we use data or a data graphic or a visualization? Should we always strive to use one? If our numbers look boring, should we turn it into a pie chart? I tend to think that we shouldn't. Tables are useful for a few reasons. They're useful when you need to look up individual values. You need to know precisely what that number is. When you need to compare values. When you need precision. Hard to get a lot of precision on a bar chart, for example, particularly when there's a really large y-axis range. When you need to look at multiple units of measure. Hard to do that on any sort of a graphic. And when you want to show details and their sums. This is generally what a table is good for. So let's talk about a graph. Graphs are useful because they show trends, patterns, outliers, and an incredible amount of data all at once. So here, this was a sample done for a consumer packaged goods company. And they're measuring brand awareness across all the different sales channels that they sell in. And immediately you can see grocery dominates, drug, maybe some sort of promotion, in various drugstores has started in September, and we've seen a huge uptick there. You think a good visualization forces you to think about the content rather than the visualization itself. We're not talking about how this pie chart was, or this line chart was put together. Instead, we're trying to figure out what's going on, what is it trying to tell us, and that's the hallmark of a good visualization. So, we talked earlier about pre-attentive attributes. I'm going to zoom out of this just a little bit. And these were defined by Colin Ware, a researcher we talked about earlier. And there are quite a few. I'm not going to go into all of them today. Certainly, if you want some of these sources later on, feel free to find me afterwards, and I'd be happy to share them with you. But these are the pre-attentive attributes that our brain naturally senses. Our visual system naturally is able to perceive these without even thinking about it, ahead or even without cognition. Of the ones you see here, which ones do you think are good for presenting quantitative values? Is that question clear? So which one of these attributes would you use to show numbers? Or differences in numbers?
2D position.
2D position. Yeah, definitely. A very powerful way of showing quantitative values. Anybody else?
Length or size?
Length and size.
And or, yeah.
Yeah. Length, we use that in bar charts all the time. Size does show a difference. You can see that the big dot is a lot bigger than the small dots. What the human brain isn't so good at seeing, though, is how much bigger, or what that value is in relation to the smaller dots. And so, if we are to take a look, the green ones here, the ones that I've highlighted in green, show attributes that are particularly effective when it comes to encoding quantitative data. And the yellow ones do the job, but not nearly as precisely. They're not as effective. Size, it's hard to determine. The human brain is not that good at discerning area. Width, how much thicker is that thick line versus the thin ones? Intensity, we can see that different dots might be darker than some others, but it's hard to judge by how much. This makes the process of presenting quantitative data quite simple, actually. It reduces the number of choices we have in the vast majority of cases that we see today, and we do this for a living, we design dashboards for a living. If you want to break down the most effective things, they can be broken down into 4 categories. We have points, which utilize 2D position. Bars, which is length. Boxes, which is a combination of 2D position and length. I'm not going to talk too much about these today, but the boxes you see here are known as box whisker plots. Really good for showing distributions. And lines, of course, for showing trend. And depending on the type of problem you want to solve, you pick the appropriate tool for the job. For example, what are bar charts very effective at doing?
Trick comparison.
Yeah, they're the best for making comparisons between values or between bars, showing differences in magnitude, etc. They can also be used for showing a trend, but the line chart shows that a bit more saliently, doesn't it? So, in terms of choosing the appropriate tool for the job, really, you can narrow your choices for the vast majority of business questions, in our opinion anyway, down to these 4. Point charts, scatter plots, very effective, especially if you're showing 2 different quantitative axes. Bars for showing comparisons, trends, change. Boxes for showing distributions, and lines, of course, for showing trends or patterns. For doing time analysis or analysis along a scale that's in order. 2, show the data and please do not distort it. If you aren't sure what to do, at the very least, try not to distort it. This came up earlier, but how many of you can guess what the value of this class is? I provided the value of my other classes, just by judging the length of the bar. Any guesses? 62, that was remarkably precise. Now I've put in the y-axis, and how close were you? And so what is the value of a bar chart when you actually need to put the numbers on it to help people know what it means? The only useful part of a bar chart is the length of the bar. And when you misrepresent the y-axis, and we see this a lot, and it's even a default on a lot of different software offerings out there, you're essentially lying, as a gentleman mentioned earlier, about the data. And this is a form of just data distortion, or what we know as the lie factor. If we were to change the y-axis to 0, this is what that bar chart actually looks like. It doesn't exaggerate the differences. But there are times where you actually want to highlight the differences in the value, especially if they're all really close together. It's kind of hard to see what the differences are sometimes. So what's the solution there? Any ideas? If I don't want the y-axis to start at 0 and I want the differences between these values to be a little bit more visually profound. Any ideas to how we could design this a bit differently?
Start Y at 60.
Start y at 60. But then we introduce the lie factor again, don't we?
Okay.
So without lying,
Well, you can keep the same scale, but start at 60. Like essentially the space between 60 and 80, for example, would just start it at 60. It would just be a very narrow graph.
yeah.
I tried to defend the young lady there a little bit.
Yeah. Well, it's the most obvious option. One thing I don't really see people doing is just, well, okay, this is not the way to do it, by the way. How many of you see a problem with this? Or actually, sorry, what is the problem with this? Yeah.
The line, like, points are connected.
Yeah.
They aren't, it's not a trend, it's just facts
Yeah.
that are unrelated.
Yeah, these are categories that have nothing to do with each other, and we're linking them together as if it were a trend. In the absence of that, and you can also do this, pivot it the other way, show it horizontally, is just to show a dot. And this takes up the lie factor. We can start the scale at something even more ridiculous, like 68. It's not always the right thing to do. It really depends. You have to use a little bit of judgment here as to, are you exaggerating something? Is there a possibility by doing this that you're misleading a person? And these differences, which look really large, aren't actually that big at all. Show the data and do not distort it. How many of you, any guesses as to what the value of the fourth quarter is?
12.
12. It's not
15.
bad. Sorry?
50.
Yeah, not bad. What is the, in terms of pre-attentive attributes, what does a pie chart use here? If you remember some of the pre-attentive attributes. We're judging area, aren't we? And what's wrong with the area that we're showing here? Well, yeah?
I actually had a question about the pre-attentive attributes.
Yes?
So I studied cognitive psychology in undergrad, and to my understanding it was more about, has nothing to, it's precognitive, right? So
Yes.
it's not something we can be attentive to. So I'm not sure, I don't know, I guess I'm just challenging how you're using that word here, because I'm not sure it's the appropriate.
I'm not a cognitive scientist,
I know.
so for me, I am just studying it. What it means to me is that our human sense isn't naturally tuned to discerning differences in values with some, and that if we break some of the rules, we could mislead people or distort the data. Does that make sense?
Yeah.
Okay.
Yeah, I'm not sure that's what the term means in psychology, though, but
Okay.
yeah.
You can correct me later, if
Okay.
anything. I'm open to being wrong.
Okay.
But what we're doing here is, by pivoting this pie chart and putting it in 3 dimensions, we're actually exaggerating the slice of the first quarter here. And so this is what it actually looks like without that perspective. But it's still kind of hard to get a sense of what the fourth quarter value, isn't it? Well, what if you weren't to use a pie and you were simply to use a bar chart? Simple as that. So, moving on. Show context, relationships, and causality. This is actually a sample that we've built on a dashboard. This is a piece of it. And here we're trying to show different agents who work at a call center. And FCR means first call resolution, meaning on the first call, how many of these agents are actually resolving the problem that's been presented to them by the caller? And we could actually improve this a little bit by showing you, this is a variation on something called a bullet graph. To show, to use bars and length of a line to show differences in value. But what if an agent's simply having a bad week? Let's pick on somebody here. Let's take a look at Heidi. Her first call resolution percentage this week is 73. 73% of the calls that she takes are resolved the first time around. And what if she's just having a bad week? What if she normally does really good? So how can we enhance this data graphic to show maybe a trend over time? So what's the first thing most of us would do? What's the first type of chart you would use to show different trends? Line chart? So here's what a lot of us would do right off the bat. And we introduce a few problems here, obviously. Quite like the pie chart with many slices. You have to make a lot of different trips left and right to figure out what the colors mean. It's almost impossible to see what's going on here. It's a mess of lines. Edward Tufte, who we mentioned earlier, quite a while ago actually, invented this concept called a spark line. And it's very simple. It's just a line chart, collapsed axes, and it shows you just the shape of the line. It's not a precise tool. It just gives you an idea of what's going on. So if we go back to Heidi, we can see that 73 is actually one of her better weeks. And so it's, we actually know somebody called Heidi. Sorry, Heidi. What we've done here is by introducing more data, we've shown a little bit more context. We're trying to paint a better picture of what's going on at this call center. And we can also introduce a little bit more. AHT, sorry about all these acronyms, they're quite commonly known in the call center world, is average handling time. How long does it take, on average, for you to handle a call? And this is measured in minutes. And we can see Heidi right now is averaging at 26. But that's today. All it takes is a couple of calls with some really complicated cases, and that could really change the average. How useful is this average actually? What we've done here is actually show all the different calls that are being made in a table format. And so the y-axis, which is presented horizontally here, shows you, represents minutes, and the squares represent calls and the triangles represent chats. And what you can see here, instead of seeing just a bunch of averages, because they're maybe not all that useful, is to see where some of the outliers are, things that are far off to the left or to the right. And because dashboards and a lot of visual software are interactive these days, all you have to do is just click on it to figure out which call that was and get some more transactional level detail on it. So very quickly, by adding more data, as counterintuitive as that sounds, we add context, we show causality, we show a little bit of mechanism, and we try and explain things as clearly as we can. And that's really the goal of a data graphic at the end of the day. And this goes to our next principle, which is to clarify, add detail. As counterintuitive as that sounds. Edward Tufte's quote here is that when it comes to presenting data and information, and most unconventional design strategies revealed, to clarify, add detail, just like we did there. Last principle, if you guys are still with me there. Good design is as little design as possible. And to demonstrate what this means, I'm now going to talk about dashboards. I haven't really talked about them. That's our core business at Dundas. We're going to explain what that is and why having as little design as possible matters. So, 3 ways we consume data today. There are many different ways of slicing it. These are just 3 that I've chosen. We have reports, we have ad hoc analysis, and we have dashboards. I'm going to explain what they are. Reports, you probably know what they are. Anything presented, typically in tabular form. It's very free-form if you use Excel, Access, Crystal Reports, any sort of reporting software out there. That's all you're doing is you're creating a report. They can span many pages, they could be on one. They're not particularly purpose-built. The reason I'm describing that is because reports are multi-purpose, dashboards are not. So that's the first distinction. Ad hoc analysis tools. This is a snapshot from our software, and it's basically, I don't know if you've seen anything like this before, but it gives you a canvas in the middle that you can just drag and drop different metrics onto to see the shape of the data. Ad hoc analysis tools really are, today anywhere, are primarily used by technical people with background in quantitative analysis, data scientists, data analysts. But they exist because you might not know what you're looking for sometimes. And so this allows you to explore and discover new things. So that brings us to dashboards. What is a dashboard? There are many definitions that I hear when I talk to people. People will say, well, it's a graphical way of showing numbers about your business. We'd like to be a little bit more precise than that. To us, a dashboard shows you only the most important information, so not everything, only that which is critical. And it needs to be critical in order to achieve business objectives. So it's not just important, it's important to you specifically when it comes to achieving the mandates that you have in your jobs. And this information is presented to you at a glance. So it's not over many pages, certainly not over hundreds of pages. I've dealt with reports that have been quite thick in the past. This is meant to be at a glance. And that's an important distinction as well. How many of you use dashboards today? At work or, okay. It's not very many of you. Why? How many of you actually have access to dashboards? Maybe this is a better question, but don't use them every day. Can you offer any reasons why?
Why?
Why you might not use them?
They're not detailed. They're just good for like giving you the information that you need, but they are not as detailed as they.
Okay, so it's data that's might be relevant, but it's presented at a pretty high level, and it's not detailed enough to actually action on it. Adoption rate for not just dashboards, but business intelligence tools, as this industry is called in general, is under 30%. And you think about the fact that $14 billion are probably going to be spent this year on business intelligence tools worldwide, that's a pretty appalling number. We've narrowed it down to 3 reasons that make dashboards successful. First of all, the data has to be relevant, and relevance also pertains to granularity. It's not only relevant, but it's relevant at a level of detail that's actually useful to you. Integration. It's hard for a lot of people to remember to use another tool or to pick up or click on something. Here on this snapshot, we've integrated dashboards in so that you actually get notified on your mobile devices whenever a number hits a certain level or a problem happens, or just every Monday morning at 8 o'clock before your meeting. This level of integration has been very successful in our experience in getting adoption and helping people use the tools available to them. The last one is design, and that's what I'm about to talk about. So this is not one of ours. I've blocked out the name of the company at the top. And it's not to be mean-spirited, but any thoughts about this dashboard? Yes?
Chromostereopsis.
I'm sorry?
Chromostereopsis. That means cold colors are going backwards, warm colors are going forwards on a gray background, and it's messing with your mind.
Wow, that's okay. Yeah, that's much better than I could have put it. Thank you. Yeah, it's definitely true. Did everybody hear that?
Messes with your mind.
Well, the colors are reversed, and they're all in a gray background, and it's messing with your mind. Anybody else? Might be a bit hard to see. Some of the things that I've noticed, some of the charts are remarkably small, very hard to read. Legibility, obviously, incredibly important. The table has 2 decimal places, and we're showing millions of dollars. It might be useful in some businesses, but quite often, maybe you're just showing an unnecessary level of precision.
Actually, real quick,
Yeah.
is like one of the things that I first thought when I saw this is something from like 1993.
Yeah, it's an old one.
Is it like it's does a dashboard need to be relevant to today's design expectation?
I think that today's design expectations are more evolved than they were back then. And so my answer would be yes.
But okay, so yeah, so you could have a great graphic, but if it's presented like something from 1993, people are not going to bother looking at it.
Well, I think this one's pixelated for one, and it looks pretty low res.
Yeah.
That could be part of it. If it were useful, I'd still use it. So there's some design details here that are clearly behind the times, or just less than optimal, that would definitely impede use. But things have changed. What's sad, though, is that this is what a lot of software out there still looks like today. Not just in terms of the resolution, that has improved a lot, or the typography, but just in terms of design paradigm. They force you into quadrants or 6 boxes when maybe you don't need 6. There's a lot of inflexible software out there today. So it might not be the fault of the designer, it's just simply the tools they had access to. Any problems with this with regards to layout? Yes?
A lot of wasted space by not integrating some common elements, which I hope are the legends across graphs.
Yeah.
Maybe you can-
Yeah, so within the different sections, sorry, it's not quite legible at this resolution. Or it's not legible, period. But yeah, there's a lot of wasted space within the graphics themselves. Yes?
I agree that some of these graphics don't make good use of the space, but the concept of wasted space is one I have to fight against all the time for many years, mostly from math backgrounds or other backgrounds, and the use of some or a lot of blank space is actually better for perception. So
Okay.
I would have to say that when I hear wasted space, it's like not that again.
I think, so you're saying that some white space is valuable
Yep.
for the purpose of perception. I certainly think that's a valid point. It's important not to have something that's too busy. But certainly if you look at the amount of space that's just used for navigation here, it takes up an incredible amount of space. In a lot of samples that you see online, you see massive titles or an enormous amount of space dedicated to the company logo. And as benign as that might sound, when these things add up really quickly, and what a lot of our clients end up having is a dashboard that's pushed pretty far down the screen. This is especially problematic with some of the newer laptops that have wider aspect ratios and they don't have as much height. And it forces you to scroll. And when you scroll, what happens is you tend to forget what you were looking at before. And this is why having everything visualized at a glance is important. This is one example of having to scroll. There's so much space dedicated at the top to navigation or nothing that the content is pushed further down, and now as a result we have to scroll to see the entire thing or zoom out. This is something that we see quite often in dashboards today, are the dials, gauges. Any thoughts with regards to those?
Useless?
What's nice?
No, I said useless.
Oh, useless. Why?
Because they're not comparative, they're not readily comparable, and you're not driving a car, you're not checking steam in a nuclear turbine. They're just, they're from somewhere else, misapplied to here without ready appreciation of what you're trying to represent.
Yes. And beyond that as well is just the sheer amount of space they occupy. So beyond not being incredibly useful, and you can tell that something might have a problem when you actually have to show the number there as well to supplement the graphic. We do that a lot as well because we use a graphic to highlight something, and because a manager will ask for a precise number, we show the number as well. This is something taken to an extreme. But generally speaking, gauges don't work very well on dashboards. This is simple moral of this story. They occupy an incredible amount of space to show one data point. So this entire portion of the screen is showing you an incredibly limited amount of information. About that car metaphor, I just put this out there. I think it's quite easy to say what's wrong here, but we call it a dashboard. It doesn't mean that it has to look like something that just came out of a car. And so I would use that metaphor lightly, wherever possible. So what are some dashboards that we design? What do they look like today? We have the challenge in our industry of making something look good and be useful at the same time. And in the data visualization blogosphere, there's two camps. There's the it must be beautiful camp, and then there's the it must look boring and just be useful camp. We have the challenge of trying to navigate somewhere in the middle. This is one example that I think succeeds in navigating that balance. We're showing various metrics for solar and wind installations here on a tablet device. And there's a combination of different graphics here. We've got spark lines to show you a trend across all these different devices, and actually if you click on them, you can drill into more detail if you want more precise values. We've got the bars in the green. These are known as bullet graphs as well, if you've ever heard of those, to show you comparison between values.